Hello everyone. In the previous video we got familiar with the concept of wettability, and in this video we're gonna continue on the subject. And first we're gonna start with some of the concepts and how the wetting phase basically behave inside the porous media. So consider that we have a couple of pores. Let's say this is one of the pores, which is so small in diameter, and then you have another pore somewhere maybe here. It has a larger diameter compared to this pore. So this is pore number 1, this is pore number 2. So now what do you think would happen if you put so let's say this is your rock, right? So this pore here are the solids, right? This is the pore wall, so you have all these rocks. I just assume the simple straight pore here. So this is solid, and then let's assume that this rock that both of these basically pores, both of these pores are water wet. Okay, so we have a water wet rock, right? And with that, remember that we meant that the contact angle, if you have a water wet rock, then the contact angle of water would be, the contact angle would be less than 90, right? Less than 90. Sorry. 90 degree, right? And so that's how a water wet rock behave, right? The water tries to spread over the surface. Now, if you put the water in contact with both of these pores, what do you think happen? So the walls of this pore are so close to each other, right? So what happens if you put the water in contact with this pore? The water starts to adhere to the surface of this pore, right? So it creates a layer at the beginning of the pore, at the beginning of this process, right? And then the water tries to spread over the surface more and more, and since the pores of these the walls of this pore are very close to each other, what happens is eventually fills the whole pore without really the need to push it into the pore. So it starts at some point, right? If I want to magnify this process, it starts at some point, right? It wets the surface, so the water starts to wet the surface, wet the surface, wet the surface, wet the surface, and this happens at the bottom too, right? And what happens? The pore have been filled with water. So if you have a reservoir, and let's say it's a water wet reservoir, usually the wetting phase, which is the water, will fill the smallest pores due to have higher adherence capacity to be basically attached to the walls of the pore, right? How about the larger pores? So you will have, again, a surface or a film of water attached to the surface of your larger pores as well, right? So you will have this water attached here to the surface of the larger pores as well, but it doesn't fill the pore, right? Because the walls are away from each other. What happens is you will have that, right? And then in the middle of the pore you will have the non-wetting phase. So this is non-wetting phase, and this is the wetting phase on the surface. Now it doesn't matter if it's really water or oil, right? If oil is the wetting phase, the oil will fill the smallest pores, and water you can find it in larger pores. Okay, so this wettability concept changed the distribution of fluids inside your reservoir rock, right? So we mentioned this, the non-wetting phase will fill the larger pores, the wetting phase will fill the smallest pores, and what we have basically in the reservoirs is that oil and water. Sometimes we do have gas as well, right? The gas, because we mentioned previously that the attraction forces between the molecules of the gas are so small, the gas is not really a wetting phase, so you consider natural gas to be a non-wetting phase always. Alright, so what is a water wet reservoir? We already covered this, kind of a review, right? So a water wet reservoir like means that the water will adhere to the surface, it will spread over the surface, right? The adhesion tension, if you remember, was sigma OS minus sigma OW, sigma WS, sorry, oil solid, water solid, WS is equal to sigma OW, water oil interfacial tension multiplied by cosine theta. Theta is the contact angle, right? So if your contact angle is between 0 to 90, what happens? What is the cosine value? Remember the trigonometric circle. So if you are there, if your contact angle is somewhere between 0 to 90, then the cosine theta is going to be positive, right? This is the cosine theta, this is the sine theta, right? So your cosine value is always positive between 0 to 90, therefore your adhesion tension becomes positive. If adhesion tension is positive, it means that sigma OS is greater than sigma WS. So in this case, you have a water wet reservoir. So for our water wet reservoirs, contact angle is between 0 to 90. The interfacial tension of oil solid is more than the interfacial tension of water solid, and contact angle is between 0 to 90, right? So this is for a water wet reservoir. For an oil wet reservoir, however, it's the other way around. Theta is between 90 to 180. Adhesion tension is less than 0, and theta is really close to 180 for a strongly oil wet reservoir. You can see a picture of oil wet reservoir. The water tries to make a sphere on the surface, try to avoid the surface as much as possible. Oil will spread over the surface. Okay.